Dear learners, welcome to the course Electromagnetic Fields. In this video, I am going to explain Divergence Theorem. Divergence Theorem is one of the important theorems. It is almost used in later chapters in electrostatics and macrostatics and in Maxwell's equation and in electromagnetic fields. Divergence Theorem can be applied. So already we know that the definition for the divergence. In the previous video, I have explained the concept of divergence and the physical meaning of divergence in detail. So from the definition of divergence, we can write del dot f vector is equal to surface integral of f vector dot ds vector by del v as del v tends to 0. So from this definition, it can be written that surface integral of f vector dot ds vector is equal to volume integral of del dot f vector d. This equation is known as divergence theorem. The divergence theorem states that the integral of the normal component of any vector field over a closed surface is equal to the integral of the divergence of this vector field throughout the volume enclosed by that closed surface. The divergence theorem states that the integral of the normal component of any vector field over a closed surface is equal to the integral of the divergence of this vector field throughout the volume enclosed by that closed surface. This theorem can be applied to any vector field, but partial derivatives of that vector field must exist. The divergence theorem is applied to the flux density. Both sides of the divergence theorem give the net charge enclosed by that closed surface, that is the net flux crossing the closed surface. The divergence theorem converts the surface integrals into a volume integral. This is advantageous in electromagnetic theory as volume integrals are more easy to evaluate than the surface integrals. Here, this figure shows the how closed surface S encloses a volume V for which divergence theorem is applicable. Now, let us consider a closed surface encloses certain volume V. Subdivide this volume V into large number of subsections called cells. Let the vector field associated with the surface S is F vector. Then if ith cell has the volume del Vi and is bounded by the surface Si, then it can be written as surface integral of F vector dot ds vector is equal to sigma I closed surface integral Si F vector dot ds vector is equal to sigma I surface integral of Si F vector dot ds vector divided by del Vi into del Vi. Surface integral of F vector dot ds vector is equal to surface integral of S F vector dot ds vector by del V into del V. So here this is the definition for divergence of F vector. Therefore, using the equation 4, we can write surface integral of F vector dot ds vector is equal to del dot F vector into del V. For considering the entire volume, surface integral of F vector dot ds vector is equal to volume integral of del dot F vector dV. This equation is the statement of the divergence theorem, and hence the divergence theorem is proved. The theorem is very effective as the evaluation of volume integral is easier than to evaluate surface integral. In electromagnetics, it is used to calculate the charge enclosed by the closed surface. This is the important application of divergence theorem in electromagnetics. I hope you could understand divergence theorem. Thank you.